All right, folks, coming at you with another tutorial video. I just wanted to make a real specific video about how to find these t-scores and z-scores that correspond to various percentages within and between, etc. So here we go. I kind of already put these problems into the setup we need. So let's just run through it. So assuming we've got z-score, right? So the first one we've got here is assuming we've got normally distributed heights. What z-score corresponds to 1% of heights being above, right? So how do we answer that question, right? Well, all we have is prob n, right? Or I'm sorry, yeah. So we want that to be, so that's going to be two tails, right? It's given us the less than and the greater than, right? So let's just let's make that 98 for 1% above and 1% below. Looks like I'll have to go 0.98. Okay. All right, corresponding to a z-score of 2.03. So let's just make sure that that's right. If that's right, when I plug that value in, and I'm going to do a Control-C or a Command-C if you're on a Mac, Command-V, and I'm going to click this button here and say values only. Important there. Okay, so that says so that says the area greater. So what we figured out here is that this is actually a less than. It's not a between. All right, so there's our z-score. Do a Command-C again. Click here, Command-V. Again, do this like click values only thing. And there we go. So this is your cutoff z-score, right? So that number corresponds to if I programmed it like this, right? What if I programmed the mean of 70, standard deviation of 4? What we find is we need to be like 2.3 standard deviations above the mean height of 70 inches to be in the top 1% of heights, right? Okay, that is the same thing as saying I need to be 79.3 inches tall, and I'll prove it. Again, click, values only, enter, whoops, click, Command Z, Command Z, there it is. Yep. And that's the upper 1%, corresponding to the upper 1% there. Here's our between stuff that we would need. So I could also test a value. How unusual is it to be 75 inches tall, say? Oh. So this means that 89% of people are less than or equal to 75, so we'd have to do a 1 minus there to get the percent above. Okay. We could even do that right here, like equals 1 minus, click that and hit enter. Boom. There you go. Okay. So yeah, some z-scores. Let's keep going. So this says absolute value of z less than z star. So what's the cutoff, right? What z says that 80% of my stuff is between these positive plus and minus z star, right? That's what I'm trying to do here. Okay. So remember, our calculator only does percent below. So I would need to find the z-score corresponding. So 80% between means 10% above, 10% below. So I'm actually going to type, what I'm going to type here is 0.9. What I'm going to type here is 0.9. Let me undo. Okay, yeah, we're good. What I'm going to type here is 0.9. Yeah. But I want the z-score, right? So if I want the z-score, I got to program this 0, 1. Okay. So that's the z-score corresponding to 90% below, right? So it should be the case that if I command copy that number and command, so that was command C, this is command V, a little click, values only. And what else do I need to do here? Add a negative sign. Hit enter. And this one I can just pastify. Okay. And hey, look, 80% is between. So there we go. So for that, we had to do kind of a two-step, right? We had to think, okay, this only calculates the cutoff for this percent below. If I want 80% between, I need 10% above, 10% below. So this has to be 90% below to give me that cutoff z-score. Then if I have z-scores between this and that value, I'll have 80% between those two z-scores. I can also reflect this and do it with a specific probability, a specific mean and standard deviation, right? I want 0.9 below, so that would give me that number. Now I have to be a little bit tricky. That right there is the correct number to put here. Values only. There we go. But it's not the correct number to put here, right? We have to find like the difference between these. So what I'm going to do is I'm going to say equals. What is what's the difference there? What's the difference there? Click on that number, hit a minus sign, click on this number, hit enter. Okay, that's the difference. So I'm going to go here, I'm going to go equals 70 minus our little difference going on there. Okay, and so that's the value paste here. Again, click, values only, bingo, bango. So 80% of heights are between, male heights in the US are between 64.87 and 75.126 inches. And that corresponds to the z-scores we had earlier, the 1.28 or whatever. Okay, so that's any normals. That's how it runs. Let's see. We could also do t-table stuff, right? So like trapping 95% between. So for all these problems, I'm going to use degrees of freedom 30. No particular reason, it's just the first number that came to mind, but you will have to put, remember, if they give you sample size, it's 1 minus. If they give you degrees of freedom, plug it straight in. Okay. So we want to trap 95% between t and minus t, right? That kind of looks like area outside t, right? So I want 95% between, so I want 0.05 or 5% outside, right? And see, this is all about area outside here. So if I say the area outside should be 5%, it'll give me my z-score right there. T-score right there, excuse me. And these guys are nice. I mean, this symmetry is what the unimodal symmetric about zero thing is what allows us to do these convenient things with t and z-scores. So just come up here and add a minus sign for that. And yeah, we see I've captured 95% of the t's for this distribution. Okay. So these are the cutoff values. Any t-score less than that will be outside the confidence interval. Any t-score greater than that will be outside the confidence interval. So say I was given something like y bar equals 0.8 and mu naught. We'll say that's actually equal to 4. Okay, and then we'll have an s equal to, oh, what's a good number? 2, and a sample size of, we'll say, 31. Right? It's got to be one more than my degrees of freedom I decided to use for this problem. Okay, so I have this information, right? What am I going to do to it? I'm going to compute a z-score. So I need like a standard error kind of thing. So that'll be s over the square root of n. So SE equals S divided by, and I actually have to type SQRT there, square root of 31. And I'm just doing a click on that cell to repeat that value. Okay, so there's our standard error. So if I wanted to compute a t-score here, I could go y bar 8 minus mu naught 4, so that's my null hypothesis thing. Good idea. Whoops. Good idea here to add parentheses. Okay, divided by my standard error. Huge z-score, right? Well beyond this cutoff, right? What if my y bar was like 4.5? Now we see that's less. So this would have been within the 95%. So there's computing a test statistic, testing it against a regular old t-distribution there, right? Okay, all right. So let's keep going. So that was the 95% between stuff. What about 5% above? So if I want 5% above, and the only thing I have is area outside t, what I'm actually going to type here is 10%, right? Because if I need the cutoff for 5% above, that corresponds to area outside 5 above, 5 below. And that'll get me my plus and minus t values here. And there's the one I need. So I'm going to copy that value, and just so you believe me, right? We want 5% above, right? Area t less or t greater than c. So 5% above should correspond to that t value. And it does. How nice. How nice. Okay, so there's how you get the cutoff t. You just plug in area outside, understanding that area outside means above and below. So if you have 5% above, you actually need to put 10% to get this cutoff value. But then when you plug the cutoff value into the area above calculator, you see 0.05. So that's how that goes. All right, that's how that does. All right, so this one is actually, well, I'm not going to say it's easy. Okay, so what does this mean? If the absolute value of t is greater than t star, we want to correspond to 99%. So what does that mean? 99% of the absolute values of t will be greater than this cutoff value for t star, right? So area outside, that's what I want to be 0.99. Okay. And so that t star is right there. Very small t star, right? A very narrow strip would be 99% outside, right? Okay. Okay. All right. So that was t-score for 5% above, t-score for 99% outside, and t-score for 95% between. Okay. I think we're good there. I'm going to leave it at that. There's a couple t-scores calculated for you. Hope you'll find that helpful.